Okay, let's just dive right in. We need to unpack this colossal modern challenge that is reshaping basically every enterprise operation
Right.
today. I mean, if you just look at your own systems, you've probably seen this shift. We've gone from, localized servers to these sprawling microservices architectures, and we're handling petabytes of data across multiple hybrid clouds. The complexity it's not just increasing.
No, it's multiplying.
Exactly.
And that complexity, that means cascading failures are now they're the norm. It makes systems so unpredictable.
And the pressure for the market is just relentless.
Oh, absolutely. We're talking about expectations for near perfect uptime, 5 nines, 99.999% availability, plus sub-second response times, all while you're trying to cut your cloud spend. It's an impossible task for humans.
It is. Human engineers, no matter how good they are, they simply cannot scale against that.
Not against that volume of data and those expectations. No way.
And when you factor all of that in, it becomes so clear why the traditional IT operations role had to evolve so dramatically. This isn't just about optimization anymore, is it?
No, this is an evolution driven by sheer necessity. It's about moving from reactive maintenance toward, predictive and fully autonomous systems.
And that really is our mission for this Agentic AI podcast, isn't it?
It is. We want to chart that essential journey because understanding this progression, it explains why agentic AI isn't some futuristic, nice-to-have concept. It's the critical necessity for enterprise efficiency right now.
We need to see how IT ops went from managing physical boxes to, supervising AI agents.
Training them, supervising them, yeah. That's the new world.
Okay, so let's quickly lay out the timeline for everyone, because this wasn't a slow walk.
Not at all.
It was a rapid pressure cooker progression. We start with the SysAdmin era, pre-2000s, totally manual, completely siloed.
That quickly gave way to the DevOps movement, which was all about fixing the cultural and speed problems.
Right, using collaboration and, a whole new set of automation tools.
Then, around the mid-2010s, SRE site reliability engineering emerges.
A formal framework to tackle reliability at true hyperscale.
And that brings us to today, the 2020s. This is the inevitable dominance of AIOps, where artificial intelligence and critically agentic architecture are essential for self-managing operations.
Okay, let's start with the roots then, but let's be quick. The SysAdmin era, the guardian of the physical data center.
Right. Their whole world was installing hardware, making sure backups ran, and using basic monitoring tools like Nagios.
Which was basically just checking if the lights were still on.
Pretty much. The real pain point was that it was pure reaction. The workflow was just tickets and manual patching.
And then the internet boom hit.
And suddenly, downtime meant direct, immediate, visible revenue loss. That reactive firefighting model it became completely unsustainable.
You couldn't just have one hero engineer staying up all night anymore.
No, that desperation for speed is what brought us to DevOps.
And it's so important to remember that DevOps was, first and foremost, a cultural fix.
A cultural and procedural one, yes. It broke down those walls between development and operations.
The whole you build it, you run it philosophy.
It solved the agility problem brilliantly. I mean, you start leveraging CI/CD pipelines, containerization with Docker, Kubernetes for orchestration.
Infrastructure as code with things like Terraform.
Right. All of this cut release times from weeks, literally weeks, down to hours. It was a revolution in how we build things.
But I want to pause on the limitation here, because this is what sets up the need for SRE. Collaboration improved, speed improved, but the underlying complexity of the systems just exploded.
Especially with microservices and hybrid cloud.
So the human oversight was still heavy, and engineers were just drowning in alerts.
Exactly. DevOps made the development process faster, but it didn't solve the reliability problem at that immense scale. The alert volume went exponential.
I mean, if you have thousands of services generating millions of logs per minute,
relying on a human to filter that noise and correlate events across that ecosystem is, it's guaranteed to fail.
So when complexity hits that kind of planetary scale, you don't just optimize your process. You have to formally engineer reliability itself.
And that's Era 3. That's Site Reliability Engineering, SRE.
Pioneered by Google, right?
Yes. It was the necessary answer when manual operations just couldn't keep up with systems handling billions of search queries a day. And the philosophy is key here. Treat reliability not as an operational task, but as a software problem.
You apply coding skills to automate away toil.
That repetitive, mundane, manual work, exactly.
And what's fascinating is the intentional structure they built. It's not just better automation.
No, it's a measurable contractual framework.
So break that down for us. What are the core elements?
Okay, so it all starts with SLI, service level indicators. These are the raw metrics you measure, latency, error rates, that sort of thing.
The raw data.
The raw data. Then you set your SLOs, your service level objectives. That's your target. If you promise a customer 4 nines of uptime, that is your SLO.
And the really clever part is the error budget.
The error budget. That is the explicit allowance for failure. It's simply the difference between 100% uptime and your stated SLO.
And this is where the cultural tension comes in, right?
It is. The error budget is the mechanism that governs feature velocity. If the team uses up their budget too quickly, meaning they cause too many incidents, feature development stops.
It just stops.
All engineering resources get dedicated solely to improving stability until that budget is replenished. It forces that compromise between new features and absolute stability.
Yeah, it sounds perfect. They had observability stacks, Prometheus, Grafana tracking everything. They had clear rules. So where did SRE hit its wall? Why did we need to jump to AIOps?
The wall was data scale. Again, SRE provided the perfect framework, but the job of analyzing the massive volumes of telemetry still fell on human engineers.
So you still had these highly paid SREs manually correlating a slow database query with an error on some microservice in a totally different cloud region.
Exactly. The framework was sustainable, but the human analysis required to achieve 4 or 5 nines was still too slow, too resource intensive.
So enter the 2020s, Era 4, the age of autonomy.
This is the moment AIOps doesn't become optional. It becomes inevitable.
We had to offload that analytical burden onto machines.
Precisely. Human operations cannot physically handle terabytes of daily logs, metrics, and traces. It's just not possible.
So AIOps shifts the focus from human-centric troubleshooting to an AI-led process.
One that learns from all that operational data.
Okay, so let's define the core functions of classic AIOps that an AIOps engineer oversees. It's about shifting from fixing to predicting. Yeah.
That's right. The first critical function is anomaly detection, spotting real-time deviations that a simple threshold alarm would just miss.
Like a database latency spike that's statistically unusual but still technically below the alarm threshold.
Exactly. Second, root cause analysis, or RCA, is automated. The AI correlates thousands of related events across systems in seconds to pinpoint the single root cause.
Which is huge for speed.
And third, the AI moves into predictive incident management. It forecasts failures hours, maybe even days, before they occur.
Wow.
And fourth, the mundane but necessary task of noise reduction, filtering out the 99% of false positives that used to drown the human engineer.
That's powerful, but it still sounds like the AI is acting as a super advanced monitoring and alerting tool.
It is.
Where does agentic AI, the core of this whole evolution, take it that critical step further?
The distinction is action. Traditional AIOps is predictive and prescriptive. It tells the human what's wrong and suggests a fix.
Okay.
Agentic AI is autonomous and active. It doesn't just suggest a fix. It executes a complex, multi-step operational task without direct human confirmation in the moment.
Can you give us a concrete example of that? How does an agent act differently than the standard automation script?
Sure. A standard script might scale up a web server when CPU hits 80%. An agentic AI operation is. It's far more sophisticated. Imagine a complex deployment of a new microservice causes high error rates. The agent doesn't just alert, it observes the anomaly, correlates it back to that specific deployment, determines the scope of the impact based on the error budget.
It's using the SRE principle.
It is. Then it generates a rollback plan, coordinates that rollback across multiple environments, verifies the fix with real-time SLI measurements, and then it notifies the human supervisor that the incident was contained and resolved. All in what, maybe 2 minutes?
Wow. That removes the biggest piece of latency in the whole process.
The human.
The time it takes for a human to wake up, analyze everything, and implement a fix. But this raises serious questions about trust.
Of course.
If an agent is autonomously rolling back production, how do we handle the explainability of its decisions?
That is the essential challenge for decision makers right now, and it's why the human role is changing so fast. We have to move toward explainable AI ops.
So you need audit trails.
You need crystal clear audit trails that articulate the decision tree the agent followed. The human supervisor has to be able to understand why it prioritized stability over a feature in that moment.
Without that transparency, you just can't allow that level of autonomy.
Oh, can't. It's too risky.
It makes sense why Gartner is predicting such widespread adoption of AIOps by 2026. This isn't just optimization. It's a total shift to predictive autonomy and AI oversight.
Using advanced ML platforms and agentic AI tools at an ultra-scale AI integrated level.
So for the decision makers, for the C-suite listeners, this isn't just some technical curiosity. This whole evolution, it translates directly into tangible financial and operational improvements.
This is the business case.
Absolutely. The primary measurable impact is on MTTR, mean time to resolution.
We're talking about a paradigm shift. In the SysAdmin days, resolution could take hours, maybe days.
With AIOps and autonomous agents, that time drops to
What?
single-digit minutes.
Single-digit minutes, for sure.
And reducing downtime has a massive dollar amount attached to it. The cost savings are immediate.
We know from industry estimates that large enterprises can lose upward of $5,600 per minute of downtime.
Per minute. That's staggering. Minimizing that exposure is enormous.
But it's not just about avoiding losses. It's about creating a competitive edge. This shift makes operational efficiency a strategic enabler.
Wow, so.
While we see clear examples, AIOps enables much more accurate, predictive scaling of resources that actively cuts cloud bills by 20–30%.
Because you're only provisioning what the AI predicts you need instead of over-provisioning just in case.
Exactly. Or think about security. When you apply AI to operational data, you start detecting subtle fraud patterns hidden in the ops logs.
Preventing breaches before they even escalate.
Which is absolutely mission critical in finance or healthcare.
And this brings us right back to the human element. The role of the engineer has changed completely.
Radically, the required skills have shifted.
We've moved from manual ops skills, bash scripting, Perl, to automation skills like Python and Git in the DevOps era. What are the core competencies now?
Now, the skills are focused on data literacy, AI oversight, and AI governance.
So the engineer isn't the operator or the fixer anymore?
No, they become the supervisor and the trainer of the AI model. Their job is to ensure the integrity of the data that feeds the agent, validate the model's decisions, and ensure the ethical and accurate use of those decisions.
That's a huge psychological shift, though. You're not coding the solution anymore.
You're validating the code that wrote the solution.
It requires a completely different mindset. It's all about governance and auditing these autonomous decisions.
It is. The engineer needs to know how to design the guardrails for the agent. I mean, if you give an agent the goal of achieve 99.99% uptime, the human has to make sure the agent doesn't achieve that by, say, just denying all incoming traffic.
Right. That's a perfect SLO, but a terrible business outcome.
Exactly. The human is responsible for defining success within ethical and business constraints.
So, to summarize this whole journey we've just taken, we've moved from engineers manually wiring servers in a siloed data center
to engineers designing, training, and supervising autonomous agents that manage these distributed hyperscale ecosystems.
And the key competency required at every single step, from SysAdmin to SRE to AIOps engineer, has been
adaptability.
Adaptability.
Yeah.
And today, operational efficiency is clearly not just a cost center.
No, it's the fundamental strategic bedrock for any successful digital transformation.
And this journey isn't finished. The ultimate horizon we're all looking toward is fully autonomous SRE agents.
AI systems coordinating their own fixes, training their own successor models, achieving self-healing without any human intervention.
Self-healing infrastructure is just going to be the expected standard.
But the crucial question, and this is for every listener to think about, while the dream of new ops, a truly operations-free environment, is aspirational, the immediate future is a hybrid model. It has to be.
Right.
So if the AI handles every routine task, every anomaly detection, and every predictive fix, where must human ingenuity focus to ensure true resiliency?
The complex edge cases.
The complex edge cases that the AI models haven't encountered yet. That gap, that 1% of novel failure, that's where the human supervisor earns their value, ensuring the system can survive the truly unprecedented.